Good day everyone. In today's lesson, we're going to consider power rule. It's a shortcut to finding the derivative of a function. Let's assume our function is f of x is equals to s raised to power n. Now if we're finding the derivative of f of x with respect to x, as f prime of x is abbreviated as f prime of x, and as we'll bring down the power, which is n, then we'll reduce the power by 1. Let's take an example. F of x is equals to x raised to power 5. So what's f prime of x? That's the first derivative of f of x with respect to x. And that's going to give us what? We bring down 5. Good. And we reduce 5 by 1. 5 minus 1. And we're going to have 5x raised to power 4. So you can try f of x is equals to s raised to power 7. Now, what if we have a constant beside s raised to power n? Let's say we have something like this: f of x is equals to a s raised to power n. It still doesn't change much. F prime of x is equals to, we bring down the power, which is n. We still have our constant in there. Then we reduce the power by 1. Let's take an example. Let's say we have f of x is equals to 3s raised to power 7. Alright, so what's f prime of x now? So we'll bring down the power, which is 7, multiply by 3, our constant. Then we'll reduce the power by 1, 7 minus 1. And we're going to have 21 s raised to power 6. So we can try this as an exercise. That's 2x raised to power 3. Let's take another example. F of x is equals to 1 all over x. Using the law of indices, we can rewrite this as x raised to power minus 1. So f prime of x is going to be, bring down the power, negative 1, and we reduce the power by 1. We're going to have negative x raised to power negative 2. Alright, let's try another one. Let's say we have f of x is equals to 4 over s raised to power 3. So we can rewrite this to be f of x is equals to 4 multiplied by 1 over x raised to the power 3. And this can be written as 4 multiplied by x raised to the power negative 3. That's our f of x. So what's the derivative of our function now? That's going to be, we bring down negative 3 multiplied by 4. Then we reduce negative 3 by 1. Negative 3 times 4, that's 12, negative 12. And multiply by negative 3, negative 1, that's going to give us negative 4. So our final answer is negative 12 s raised to the power negative 4. So we can try this as an exercise. 5 raised to the power 5 over s raised to the power 6. Right, let's take another example. Y is equals to root of x. In place of f of x now, we have y. Now we can rewrite this as y is equals to s raised to power half. Yes, root of x can be written as s raised to power half. So what's the derivative of y with respect to x? We can abbreviate that as y prime or dy dx. You can use any of these two. So we bring down the power, which is half, and we reduce the power by 1. That's half negative 1. So then we have half s raised to power half negative 1. That's going to give us a negative half. That's what our y prime is going to give us. What if we have a cube root? Let's say we have y is equals to cube root of x. So we can rewrite this as y is equals to s raised to power 1 over 3. Alright, so our y prime now, we bring down, that's 1 over 3, we bring it down, then we reduce 1 over 3 by 1. So what are we going to have at the end of the day? That will be 1 over 3 s raised to power 1 over 3 negative 1. That's going to give us negative 2 over 3. Let's take another question. Let's say we have y is equals to the cube root of x raised to power 7. So what's the y prime of this? Let's rewrite the cube root of s raised to power 7. S raised to power 7, everything is raised to power 1 over 3. Okay, and this becomes, using the law of indices, that's 7 over 3, 7 times 1 over 3, and y is going to give us 7 over 3. So y prime now, we bring down the power, which is 7 over 3, then we subtract 1 from 7 over 3. So at the end of the day, we are going to have y prime, and that's going to give us 7 over 3 multiplied by x. 7 over 3 negative 1, that's going to give us 4 over 3. Let's take another one. Let's say we have y is equals to the fourth root of x raised to power 3. Alright, so let's rewrite this as s raised to power 3, 1 all over 4, which is the same thing as s raised to power 3 over 4. So very easy, we bring down the power, which is 3 over 4, and we subtract 1 from 3 over 4. So at the end of the day, we are going to have 3 over 4 s raised to power 3 over 4 negative 1, that's going to give us negative 1 all over 4. Let us consider this example. Y is equals to the reciprocal of the cube root of x. Alright, we can rewrite the denominator as 1 over s raised to power 1 over 3. Using the law of indices, this becomes s raised to power negative 1 over 3. So the y prime, the derivative of y here, we bring down the power, that's 1 over 3. Then we subtract 1 from the power, and that's going to give us y prime negative 1 over 3 x raised to power negative 4 over 3. Okay, let's have another example, that is y is equals to 2 over the fifth root of s squared. Okay, so what do we have here now? Let's rewrite this. This will be 2 over s squared raised to power 1 over 5. Alright, still using the law of indices, so this is going to be 2 over s raised to power 2 over 5. That's 2 times 1 over 5. That's 2 over 5. Okay, we can rewrite this as 2 multiplied by 1 over s raised to power 2 over 5. So still using the law of indices, y is equals to 2 multiplied by x raised to power negative 2 over 5. Okay, so we bring down the power, that's negative 2 over 5 multiplied by 2 multiplied by x, then we subtract 1 from the power. So at the end of the day, we have negative 2 times 2, that's negative 4 over 5, negative 2 over 5, negative 1, that is going to give us negative 7 all over 5. And that's our final answer. So we can take this as an exercise. Differentiate y is equals to 3 over, let's take the 7th root of s cube. Thank you for watching.